So today we're going to talk about volume properties. Our objective today is that students will be able to calculate the volume and surface area of cylinders and prisms. One application of this is, for example, I might want to figure out the volume of the tins that I'm using to bake muffins and figure out how I can best distribute my muffin batter or how many muffins I can make with a single batch. So right now I'd like you to pause this video and write down one other application of finding volume of an object. Thanks for working on that. Now we're going to scroll down a little bit and let's start our notes. So our first question is, what does volume mean to you? We asked this question about area when we were taking our notes on area. So this time we're asking about volume. What does volume mean to you? Go ahead, pause this, write down your own definition in your own words. Okay, so hopefully you have a definition in your own words. When I think about volume, I think about how much space a three-dimensional object takes up. Okay, and really the important part of this is that we're talking about something three-dimensional, right? So if I have a flat shape, for example, a square, right? A square does not have volume. A point on a graph does not have volume, but a box has volume. A cylinder has volume. A prism has volume. So let's continue on with these comparisons of area and volume and see if we can figure out some of the properties of volume. So what I'm going to do is give you a property of area and then ask you to pause the video and see if you can think about the volume property that matches up. So let's do the first one together, and then I'll give us some time to think about the next few. So this first one says, the area property that we're talking about is area is a number greater than 0, describing the size of a 2D figure. So now, instead of talking about area, what if we take that idea and we talk about volume instead? So in this case, we get volume is a number greater than 0 That just means that we can't have a negative volume or a volume of 0, right? Something that has volume has to have size. So a number greater than 0, describing the size of a 3D figure, right? And the only difference between area and volume here is that area is about two-dimensional figures and volume is about three-dimensional figures. So our next one says, area of a rectangle is base times height. So now I'd like you to pause this video and take a moment to think about what would the analogous volume property be. All right, so let's talk about volume. The figure in 3 dimensions that's analogous to a rectangle is a rectangular prism, right? So here, instead of saying area, we're going to say volume, right? So volume of a rectangular prism is, and we've already done this in an earlier lesson, but it's length times width times height. So that means that rectangle became rectangular prism, and base times height became length times width times height. We also talked about the fact that we can find volume to be the area of the base times the height. So this is, of course, it's the same thing as length times width times height when we're talking about rectangular prisms specifically, but this is much closer to the corresponding area property. So number 3 says, congruent shapes have the same area. Now go ahead, try to write this sentence as something that pertains to volume. So we were thinking about congruent shapes having the same area. For this one, we're going to say congruent 3D objects have the same volume. So what this means is that if I have two boxes that have the same measurements, that means the volume is the same. And that's pretty standard, right? That feels very intuitive to us. Now we're going to come back to number 4 in just a minute. Let's talk about number 5. So number 5 says we can estimate area using unit squares. So I'd like you to think about that and see if you can make it into something about volume. So hopefully you've thought about number 5. Number 5 says we can estimate area using unit squares. We're going to change that to we can estimate volume using unit cubes. Right? So the idea here is that we changed squares to cubes and we changed area to volume. Now going back to number 4, what I would like you to do in number 4 is come up with your own property of area. Now this can be anything we learned about area, right? You could say something about similarity, you could say something about things being larger or smaller than another thing. You could say something about triangular prisms or about trapezoidal prisms, right? You have lots of options, but in this area, I would like you to make up your own. You can take a moment now to pause this video and do that. Okay, thank you for working on that. We're going to come down here and we're going to generalize the volume of a cylinder. So we've already talked about this in a previous lesson, so I'm not going to spend a really long time thinking about it. But the volume of a cylinder is the area of the base times the height. Right? And this is just a general formula for the area of a cylinder. So let's do an example. So what this example says, find the volume of a triangular prism with side lengths 3, 4, and 5 and height 7. So what if I have this triangle, this is the prism I have, and my triangle on the top and the bottom, my bases, are 3, 4, and 5. Now on the bottom I also have 3, 4, and 5, right? And I know that my height is 7. So the first thing I need for my volume formula is the area of the base. And then I'm going to multiply that by the height, right? So to figure out the area of the base, I need to figure out the area of this 3, 4, 5 triangle, right? And we should know, looking at these measurements, that this will be a right triangle. 3, 4, 5 is a Pythagorean triple, which means that if those are the side lengths of a triangle, we have a right triangle, where the legs are 3 and 4, and the hypotenuse is 5. So to find the area of this triangle, our base is 3, our height is 4, because it makes a right angle with our base. So the area of this triangle is 1/2 the base, which is 3, times the height, which is 4, which comes out to be 6. So that means the area of the base is 6. We also know that our height is 7. So that means the volume is the area of the base, which is 6, times the height of the cylinder, or of the prism, which is 7, and that gives us 42. And that means that our answer is 42. Now let's move on to figuring out surface area. Surface area is a little bit different. Surface area and perimeter are very similar. Perimeter is the area outside a shape, right? If I were to build a fence around the shape or draw a line around my shape, how far would my pencil go? Or how long would my fence be, right? Surface area is if I were to paint an object with paint, how much paint would I need? Or if I were to wrap an object in wrapping paper, how much wrapping paper would I need? So just to look at some intuitive examples, we're going to look at two things from my kitchen. When we are thinking about surface area, we can pretend we are figuring out how much wrapping paper we need to cover an object. Here I'm going to demonstrate this idea with a box of graham crackers and a can of soup. There are lots of ways I could have cut my pieces of paper to cover these objects, right? I could choose to cut one piece for the top, one piece for the bottom, and one piece to wrap along the sides, which is what I did here. Or I could have done this in a different way, right? I could have wrapped around the top to the bottom and done flat pieces on either side. I could have made each piece its own individual piece, but this 3-piece method is the easiest way, I think, to see what we're really doing here. So the first thing we need to notice is that the pieces on the top and the bottom are the same size because the bases of a cylinder or prism are congruent. What is the area of these pieces? Well, it's just the area of the base. Now we just have one piece left, this piece that wraps around the outside. This piece is a rectangle, which means we can find the area by multiplying the length times the width. But what is the length of this piece of paper, and what is the width? Well, we know the edge of this paper wraps around the entire box. If we look at the top of the box, we can see that this is the same as the perimeter of the base. What about the width? Well, the width of this rectangle is the same as the height of this box. If I put all of these pieces together, if I add each of these areas, I get the surface area of the entire box, how much paper I need to cover the entire thing. We'll talk about putting all of that together in a minute. First, let's discuss one more example. For this, I'm going to use a can of soup. Again, I cut 3 pieces of paper for this surface area problem. One piece for the top, one piece for the bottom, and one to wrap around the outside. The area of the top and the bottom pieces are both the area of the base. In this case, I would find the area of a circle. The third piece is still a rectangle because it was still wrapped around the outside. To figure out that area, we can multiply the length, which is again the perimeter of the base, in this case the circumference because we're talking about a circle, by the width, which in this case is the height of the can. Now, if this was confusing to you, I highly encourage that you go grab some paper and some food container from your kitchen and try this yourself, right? Especially that piece that's wrapping around the outside, the perimeter by the height piece. Try that. See if you always get a rectangle. You should. Now we can go back to our notes and develop a formula that puts each of these pieces together. Now what we saw when we were looking at those objects is that the surface area is made up of 3 parts, right? So surface area is 3 individual pieces, right? I had 3 pieces of wrapping paper for both of my examples. So the first piece of wrapping paper is the part that went on the top. So if I had my box, right, that first piece of wrapping paper was the top. And the area of that top piece was the area of the base. Now the second thing that I had was that bottom piece of wrapping paper, right? And that was also the area of the base, right? We know that the top and the bottom are exactly the same. So we're going to add another area of the base. Now that last piece of wrapping paper I had was the tricky part, right? And that wrapped all the way around my figure, right? It went around the outside. It wrapped around the outside. And when I unrolled that, what we saw was that was the height of the cylinder, right? We had the height of the cylinder times the perimeter of the base, right? That's how long that piece of wrapping paper was the perimeter. Now, if we take this whole big thing, right, area of the base plus area of the base plus the height times the perimeter of the base, I'm going to put that together in a more easy to see fashion. So really, if I take the area of the base and the area of the base and I add those together, I get 2 times the area of the base, right, plus the perimeter of the base times the height, right? So I have 2 times the area of the base plus the perimeter of the base times the height. So let's do the surface area of our previous example, right? So let's think about that same triangular prism where I have 3, 4, 5. Now my base is the same. We already figured out that the area of a 3, 4, 5 triangle, area of the base, we know that that is 6. So what else do I need? I have the area of the base. Now I need the perimeter of the base. How do I get the perimeter? Well, I'll get that by adding each of my outside pieces. 3 plus 4 plus 5. 3 plus 4 is 7, plus 5 is 12, so my perimeter is 12. And then I just need my height, and I know that my height is 7. So height is 7. Now I'm just going to plug that into my formula, right? And I get surface area is equal to 2 times the area of the base, which is 6, plus the perimeter of the base, which is 12, times the height, which is 7. And the surface area I get is 12 plus 12 times 7 is 84. 12 plus 84 is 96. So our surface area is 96. If this were in inches, that would be 96 square inches of wrapping paper that I need to cover this object. So that's actually it for our notes. These notes should be pretty straightforward for you all. If this video didn't help you in any of the specific areas, I'll be posting some Khan Academy links that will hopefully help you. Remember that we also have coach classes if you need them, and that you can leave comments on these videos to get extra help. Have a wonderful day.